All right, so the last topic in chapter 5 is 5.7. Talk about atomic radii. So that's the actual diameter, or not diameter, but the radius of an atom. So again, we talked about this before. The radius is going to be the distance from the centroid out to the periphery. And this is sort of a loose number just because atoms, as we know now, aren't hard spheres. they're a bunch of mass in the center where the protons and neutrons exist, and then they're a really diffuse outer layer. And so the actual atomic radius is defined because it's not a real thing. It's defined as what is half of the distance of the actual width of a molecule of that particular element bound to itself, which is a really abstract idea. But it gives us some sort of generalization for a radius. And so it's less important exactly how this is deduced, and what's more important is getting back to the original question in the first video in this series in chapter 5, which had to do with periodicity. Remember, periodicity is the idea that chemical trends change or track with how they exist on the periodic table. So as you can see here, I've got a periodic table that just sort of pictorially and numerically represents the different atomic radii as they move across and down the table. So if you think about the atomic radius as you go down a group, it makes pretty intuitive sense that they get bigger, right? And that makes sense because we're actually increasing the size of our shells from n equals 1 to n equals 2 to n equals 3, and we know that the principal quantum number of any orbital really speaks to the size and the energy. And so as you move down a group, you get bigger. What's a little bit less easy to understand, though, is what happens if we move, say, across a row. So if we're moving across a row here, say from sodium to magnesium to aluminum to silicon, we can see that we're actually decreasing in size as we move across, even though we know that the atomic number is increasing, or in other words, the nucleus is getting bigger, right? We're packing it full of protons and neutrons. The reason this is the case is because as we move from left to right, that effective nuclear charge, it gets bigger. And the reason it gets bigger is because the number of these protons is going up, but the actual shell size, or the distance of those electrons from that nucleus, it doesn't change. Right? So if you think about this from a perspective of, this is kind of hand wavy unless we did some math, but we don't do much math in this class. If we've got the nucleus, which may be this purple dot in the center, and we've got all of our electrons in one subshell, we'll say this is maybe n equals 3, just to be in the subshell that we're talking about here, or shell that we're talking about here. So we got some electrons that are out here in this shell. Right? If we start packing this center, this nucleus, with more and more protons, more and more positive point charges, which is exactly what happens as we move across the table, right? We're just putting more and more of those in there. We are adding more electrons, certainly, here, but we're not adding any distance of those electrons from the center of this nucleus. So they're still the same distance. So there's really nothing in between it that's going to shield or prevent that nuclear charge. In other words, as this nuclear charge gets bigger and more positive, it's going to contract or draw in this n equals 3 subshell. So it's going to get smaller and smaller and smaller, simply based on the electrostatic pull of a positive charge to a negative charge. And that's going to be true. So we're going to get this contracting as we move from this bigger sodium atom all the way over to the chlorine atom that's on this side. It's not until we add a whole nother subshell, or a whole nother shell, maybe the n equals 4, that that z effective starts to change, and we start putting an electron way out here in a much bigger open shell. That's why we get these big changes in this direction, and then some contracting in the direction from left to right.